Okay, look, if you are relying on automated workflows to connect your critical business systems, and let's be honest, pretty much everyone is, you need to stop what you're doing and listen. Today, we're doing a deep dive into a vulnerability that is, without a doubt, one of the most critical disclosures of the year. We're talking about a severe flaw in n8n, which is a hugely popular open source workflow automation platform, and it has been assigned a CVSS score that is just staggering 9.9 out of
The
10.
number 9.9,
Yeah.
yeah, it's basically the loudest alarm bell you can get in the security world.
Yeah.
Tells you two things at once, really: maximum severity and minimal effort to exploit. For anyone listening who's maybe used Zapier or something like IFTTT, n8n is the powerful self-hosted open source version of that. It's the digital plumbing for so many companies.
Yeah.
And this flaw, CVE 2025-68613, it doesn't just mess with the workflow. It hands an attacker the keys to the entire server.
So our mission for today is pretty clear, and it's urgent. We need to unpack the CVE completely. We need to understand the technical side, how a system that's just supposed to automate things can become a doorway for remote code execution. And then, most importantly, we're going to detail the exact steps you need to take right now to get patched and lock everything down.
Okay, so let's unpack this. A 9.9 CVSS score that suggests an attacker can go from just, editing a simple workflow to owning the whole operating system. How does a leap that big even happen inside an automation tool?
It happens right in the engine room. In n8n's core workflow expression evaluation mechanism, see, NA is built to be super flexible. To handle complex logic, it lets users put in their own expressions, little bits of JavaScript, basically right into a workflow. And that's
Yeah.
the source of the problem.
But that flexibility, the very thing that makes the platform so powerful, that's the vulnerability. Precisely. The core technical problem is what we call insufficient sandbox isolation. A sandbox is supposed to be a secure, isolated little box where code can run without touching anything else in the system. Think of it like a soundproof steel room. Whatever happens in there is supposed to stay in there.
And what we're talking about here is a massive hole in the wall of that steel room.
A huge one. The user-supplied expressions, the little code snippets, they were being evaluated in a context that just wasn't isolated enough from the underlying system, the Node.js runtime. So a clever attacker can craft a special workflow expression. It's not designed to process data, it's designed to break out. They essentially find a weak seam in the wall of that sandbox, escape it, and start executing OS commands on the host server.
If we just pause on that for a second, escaping the container, what does that really tell us about the challenges here? I mean, it feels like the very idea of allowing dynamic code opens up this kind of risk.
It really highlights a fundamental tension in design. Node.js is incredibly powerful, but properly isolating execution contexts in its single-threaded environment is notoriously hard. It's not like spinning up a whole new virtual machine for every little task. Any failure to strictly limit what that code can access, well, this is what happens. It leads to full remote code execution, RCE, and the attacker is running commands with the exact same permissions as the n8n application itself.
And that's the critical piece that our sources kept coming back to, the prerequisite. An attacker needs to be authenticated, they need a login, but, and this is the key, they don't need to be an admin, they just need the most basic permission to create or edit a workflow.
Right. And this is where that 9.9 score really starts to make a painful amount of sense. A normal user, a basic one, can maybe just, move some data from a spreadsheet to a database. They're low on the trust ladder. But once they exploit this RCE, they inherit all the power of the n8n application itself, which means they can suddenly read system files, steal API keys from the configuration, and basically set up shop on your server. That basic login becomes a skeleton key.
Okay, here's where it gets really, really interesting. The scale. The sheer scale of the potential compromise here is just staggering. We're not talking about some obscure tool. The NTM stats show n8n has something like 57,000 weekly downloads. That's huge adoption.
The adoption is one thing, yeah, but the exposure is another. We looked at the data from Census, which scans the internet. As of December 22nd, 2025, they found 130,476 potentially vulnerable instances just out there on the public internet.
Over 100,000 servers. 100,000 servers running mission-critical automation potentially. That completely changes the risk profile.
It really does. And the data shows us a kind of interesting geographic footprint. The instances are everywhere, of course, but the biggest clusters are in the US, Germany, France, Brazil, and Singapore, which probably tells you something about where enterprise adoption is highest, maybe in places with strict data sovereignty rules that push them towards self-hosted solutions. It's not just hobbyists. This is in serious corporate environments.
So what's the active threat level? I know the sources said there wasn't a widely public proof of concept exploit at the time of writing, but A PCC does exist, right?
It does. Secure Layer 7, a respected security firm, confirmed they built a working PC.
And once a PUSI exists, even if it's private, the clock is ticking.
The clock is ticking very, very fast. It means the knowledge of how to do it is out there. You have to assume that sophisticated attackers have already built their own private versions. The second a public, easy-to-use exploit drops, and that could be any day now, you will see automated scanning and exploitation just explode. For any internet-facing server, the risk is right now. This is a fix-today problem. So let's talk about the actual outcomes here. If we connect this to the bigger picture, compromising the automation engine, it's like getting the keys to the kingdom.
I want to dig into that idea you mentioned before, the inherited trust, because with this RCE, the attacker is essentially wrapped in the trust that the organization gave the NAM service, right?
Exactly. The vulnerability weaponizes that trust. The n8n process, it has to be privileged to do its job. It holds all the good stuff, database credentials, powerful API keys for AWS or Google Cloud, internal service tokens.
Which means the damage can cascade way beyond just that one server.
Oh, absolutely. We're looking at 4 major outcomes. First, obviously, full takeover of the instance. The attacker can just move in and stay. Second, and maybe the scariest, is data exfiltration. If your workflows touch PII, financial data, intellectual property, the attacker has a direct line to it. Third, they can just destroy or manipulate all your automation logic, cripple your operations, or worse, insert malicious new workflows.
And the fourth one is that pivot risk, using the server as a launch pad.
Yes, the RCE lets them move laterally through your network. Your firewall trusts n8n to talk to your databases and internal apps, so the attacker can use that trust to attack the rest of your infrastructure from the inside. This is why it's a major supply chain risk. You compromise this one central hub, and you can bring down multiple connected systems all at once.
That perfectly summarizes it. This isn't just about one server going down, it's about compromising the central nervous system of an organization by leveraging the very trust it needs to function.
Okay, given the gravity of this, the 9.9 score, the confirmed POSI action is non-negotiable. For anyone listening who's running NES, you need to know exactly which versions are vulnerable and, more importantly, which ones are safe.
Right. The scope of affected versions is pretty broad. It starts at version 0.211.0 and goes all the way up to the new fixed releases. And it's really important to know, some earlier versions had partial fixes, but they did not fully solve the problem. The sandbox escape was still possible.
So why did those first attempts fail? What did they miss that required them to release 3 totally new patched versions later?
That's a great question. The expression evaluation engine is just. It's incredibly complex. The first mitigations probably blocked a few known attack methods, specific functions an attacker could call. But the root cause was more fundamental. It was a systemic lack of isolation. So the final patches had to do a much deeper, more structural refactoring of how all user code is executed. Okay, so if those first fixes were incomplete, let's be crystal clear. What are the 3 specific patched versions people need to upgrade to right now?
The 3 key versions that contain the full structural fix are 1.120.4, 1.121.1, and 1.122.0. You have to upgrade to one of those immediately. They contain the hardened engine that actually closes this vulnerability for good. If you are on any version before those, you're at risk. Now, for organizations that for whatever reason cannot patch immediately, there are a couple of temporary controls. But I have to stress, these are gap fillers. They are not a solution. First, you absolutely must limit workflow creation and editing permissions to only your most trusted admin-level users. Second, if possible, run n8n in a hardened environment. That means stripping down the OS permissions for the n8n process itself and locking down its network access.
But that caveat that this is temporary and incomplete, that's everything. Restricting users doesn't fix the code. You're just betting that one of your trusted admins won't get their account compromised.
Precisely. It's a gamble. If a trusted account gets phished or you have a malicious insider, the vulnerability is still there, waiting. These measures are only meant to buy you a few hours, maybe a day, to schedule the real update. The patch is the only true fix.
All right, let's synthesize the key takeaways from this deep dive. We've got CVE-2025-68613. It's a critical RCE in n8n caused by a sandbox escape. The risk is off the charts 9.9 CVSS because it only takes a basic authenticated user to get highly privileged access. And it affects over 103,000 instances out on the internet. The only real solution is to update urgently to version 1.121.4, 1.121.1, or 1.122.0.
And this whole incident, it leaves you with a really important question to think about. Given that this all stemmed from a basic user permission, It forces us to reevaluate our internal trust models. We build these complex automation systems, and we implicitly trust anyone who can log in. But this shows that in a world full of these powerful tools, giving a user permission to write code, even if it looks like a simple expression in a text box, might need to be treated with the same seriousness as giving them shell access to the server itself. So how do you restructure permissions when that line between simple user and full system control becomes so blurry?
A very compelling challenge to take forward. As always, apply this knowledge, get your system secure, and thank you for joining us for this deep dive.